Hello, good afternoon. On behalf of the IDX team, my name is Matt Jarrett, and we'd like to thank you for attending our presentation today. IDX, to put it briefly, is a group of students here at Washington State University, as well as the University of Idaho, who are working with NARA, the Northwest Advanced Renewables Alliance, on developing a supply chain for aviation biofuels here in the Northwest. As we go about our research here as students, we feel it's very important that we tie in with NARA's main goals. Like I just said, it's to produce a sustainable biojet fuel. However, along the way, there are co-products that can be made, and NARA wants to capitalize on these co-products as much as possible. However, it's not all economic here at NARA. One important aspect, is establishing rural economic communities in the four-state region of Washington, Oregon, Idaho, and Montana, and help establish these communities economically. In conjunction with that, NARA hopes to establish regional supply chains and establish communication between the various stakeholders involved in this business. Lastly, it's important to educate the public and get the word out there about what is relatively a new technology of aviation biofuel. That being said, you can't create something unless there's a demand for it. This graphic here shows that there is a great demand in the four-state region for jet fuel. And while that is concentrated over in the Puget Sound area, you can see on this graphic that there are many markets from which NARA can supply. However, it's not so easy to just go from biomass to jet fuel. There's this path that we have to take and go along it. And while this may look linear, there's a few different options along the way that the IDX team has been looking at. Right here, we're going to see the different options. Option one is an integrated biorefinery, where all those processes you just saw on the last slide will be done at one central location. However, the IDX team is also considering a depot facility plan where the preliminary steps would be done and then ship off that feedstock to a conversion would finally be turned into a jet fuel. Both of these will be looked at to look at both of these, we divided ourselves into two teams. I'm now going to pass it over to my peers to talk a little more about the different teams and the different types of sites we are looking at.
Hi, my name is Ian Smith. And so to start it off, we're going to start with naming the names for the depot team. With that is Matt Jarrett, who just spoke recently, Stephen Keith, Cody Lane, and Ian Smith with myself. And we're all students at Washington State University studying civil engineering. Brian Hansen is also on the team. He studies at University of Idaho, and he is studying bioenergy engineering. The depot team is part of the two facilities, which is the solids depot and the liquids depot. The conversion team covers two different facilities: the conversion facility and the integrated biorefinery. On this team is Sydney Diekman, Kyle Stevens, Christian Williams, and Anna Martin, and they're all students here at Washington State University and studying civil engineering as well. And to introduce you, here is the depot team analysis. And so we have two different facilities, the solids depot and the liquid depot, and it focuses on the first half of the supply chain. For the solids depot, it is strictly the mechanical pre-conversion. And that is the mechanical reduction in particle size of the biomass. So you have the biomass, and then you change that into the feedstock, which is wood chips or pellets, depending on what process you decide to take. The liquids depot takes that one step further, and so it has the mechanical pre-conversion, and then it's the liquid pretreatment, which is the mild protocol. This gets it ready for enzymatic hydrolysis. So that enzymatic hydrolysis then takes the sugars out of the biomass and then sends that on to the conversion facility. There's a couple things that makes the depot methodology a little bit different. The depot is multiple facilities of the same type, all in smaller in scale. So NARA has done an analysis on take an intake of 770,000 bone-dry tons a year and converting that into biojet fuel. A solids depot methodology would consist of 3 or 4 solids depot close to the biomass residuals and all working at the processing rate of 250,000 bone-dry tons per year. And this cuts down costs on transportation of that biomass. if you have to transport that biomass far away and then mechanically reduce the size, then that cost of transportation is rather high. The liquids depot is fairly similar, but there will only be about 2 of them working at a higher rate than a solids depot. This is because the increase in infrastructure due to the pretreatment and the enzymatic hydrolysis. So there'll be increased storage and increased type of equipment, such as a bioreactor or a reactor for the pretreatment. And so I'm going to pass this on to the conversion methodology, and that'll be Anna Martin introducing that.
Okay, so this is the narrow supply chain once again. So it starts off for the conversion process by receiving the simple sugars and fermenting them to create the isobutanol. This isobutanol is then refined, and then this is refined into kerosene. The kerosene is then blended with petroleum to create the final product of jet fuel. So there's 2 types of facilities that the conversion process looked at. The first one, the conversion facility, will change based on what kind of depot is selected in the first part of the process. If a liquids depot is chosen, it will include fermenting and refining. If a solids depot is chosen, it will also add in an extra element of hydrolysis. The most important part for the conversion facility is that you have a close proximity to the solids or liquids depot and to the end market. Relatively few considerations were put into selecting a conversion facility, or what makes up a good conversion facility compared to an integrated biorefinery or some of our other sites that we looked at. The most desired factor in a conversion facility site ended up being an oil refinery. The next type of site we looked at was the integrated biorefinery, and this was kind of an all-in-one site. So it takes the woody biomass all the way to the petroleum jet fuel. The most important factor for this ended up being the close proximity to forest residuals in the end market. And in an integrated biorefinery, there was a lot of different factors and many different considerations that kind of went into this. An input requirement to make this work was 770,000 bone-dry tons. The highest desired sites ended up having pulp mills. So, according to the techno-economic analysis, or TEA, these are kind of the costs that we would expect for an IBR facility. This is about 55% capital expenditures and about 45% operational expenditures. Right now, the price of petroleum jet fuel is about 2 to 3 times less than our biojet fuel. Okay, so in order to start picking our sites, we had kind of a preliminary site selection process. We started by considering what factors we considered important to us, and we listed and identified these factors and compared them to what communities had and what we thought was important within those communities. We basically matched up our needs and desires to the resources available within a community. We very broadly decided on why these sites were desirable, and I'm going to turn it over to Brian, and he's going to explain more of how we decided on the future sites.
Hi, I'm Brian Hansen, and this is a representation of our methodology of how we decided to pick our sites. We tried to go with a nice visual by using our GIS data and by giving each one of the counties a factor between a -5 and a +5, and where the darkest colors are going to have the most positive value. We then overlaid these and stacking them up and gave them an opacity filter of what was, we determined how much the weight, how critical it was. While biomass was very important in many of the earlier processes, this is was one of the heaviest factors. And so when we look at the final site selections, we can see there's several hotspots out here, and we decided to circle those and look a little bit more intense on those sites there. By doing this, we decided to take this broad scope that we had and break it down and go to the individual sites in these locations and determine which ones would be the best out of these sites. And Kyle's going to show a little bit more about how we went along that process and did more in-depth discovery.
All right, so I'll be kind of walking you guys through how we use this site-specific information in our analysis. And you can see that we created 4 different site selection matrices to help us out. And one was for each of the 4 facilities: solids, liquids, conversion, and IBR. And so this is an example of the site selection matrix that we use for the solids depot. And you can see that we have all of our asset factors listed up there, which are all the assets that we took into consideration for our analysis. But we had to determine which of these asset factors are actually more critical for our ranking analysis. And to do that, we relied on the coefficient of variability, which, as you can imagine, is a measure of how variable the data is for each of these factors. So our methodology behind that was, if it doesn't vary a whole lot, say for labor, for any of our sites, then it should have a smaller impact on the overall ranking of that site. We then multiplied that by the normalized, which we developed with a lot of help from Natalie Martinkus, and then made it in accordance to our asset factors. And this is basically just a measure of how important this asset factor is to our overall project. So the multiplication of these two gave us our raw asset factor, which was then normalized and set to 20 for our analysis. And the reason we set it to 20 was because each of our sites, or each of our asset factors, are evaluated on a rank from -5 to 5. So when all these are accumulated and multiplied by this normalized asset factor, it gives each of our sites a maximum score of 100, which was just easier for us to use. And next up will be Steve and Keith talking to you about a few of these asset factors.
Hello, I'm here to talk about biomass availability first. We had about 600 sites overall, potential sites to look at. So analysis was broad, that hotspot analysis. So we're trying to limit the sites to actually hone in on the site-specific factors to look into. We did this starting with biomass availability, one of our largest factors, using a biomass availability density plot given to us, and researched a break-even distance of about 28 miles, plotted that as a buffer around each site, and then got the actual volume of biomass availability around each site. We had approximately 70 sites that provided a biomass availability of over 250,000 bone dry tons, and we varied linearly from that low value to our average high to rank each site and get our top 40. Next, we looked at our electric rates. We found the electric rates using the from the Energy Information Administration. We also ranked this linearly from the average high value to average low value, obviously wanting a lower electric rate to minimize operational costs. Then we looked at our distance to markets. The further we have to either ship or rail or transport our biojet fuel, the more operation expenditure we have. this is a plot showing our top 31 sites after doing some of our preliminary analysis with the military and commercial markets shown based on size of their demand. Social capital is provided to us by Sona Rykhoff. You see here the Creative Vitality Index, Social Capital, and Poverty Rate. The Creative Vitality Index is an index that measures the creative influence or acceptance of the community. We want a community that will accept a project like this. Social capital is what does this community have to offer so that people who are employed there are happy and want to kind of stick with the project. This is a measurement of like voter census and other assets that the community has, such as bowling alleys, golfing facilities, and much more. And poverty is somewhat self-explanatory. And lastly, labor rates, which we found from the Bureau of Economic Analysis. We wanted to choose a location that had a lower average annual salary so that in theory you can offer a salary higher than the lower average to gain more incentive, lowering operational costs, but also improving the average economy in the location. And next up is Sydney Diekman to talk more about facility type scores.
So one factor that needs to be considered when you're choosing a site is what type of facility is already present. When you're looking to build an integrated biorefinery, for example, there is a capital infrastructure cost of about $726 million. So you want to maximize the amount of savings you can get by picking the most appropriate site. So on a site-by-site basis, we looked up and found out whether an ethanol plant, a chipping mill, etc. And then we looked at further into seeing what types of infrastructure they already have in place. So you could assume a sulfite mill would have nothing in place for enzymatic hydrolysis, but everything needed to do pretreatment. Then we assumed that that was how much money was being saved by choosing that type of mill. So for example, for an integrated biorefinery, a sulfite mill would save approximately $510 million out of a total of $726, which was 70% of the costs. This was the most saved for an integrated biorefinery out of all the types of facilities that are pre-existing, so it was given a perfect score of 5. Then the other types of facilities were rated according to that. So if a type of mill saved 35% of the cost compared to that 70% by a sulfite mill, which is the best you can do, you give a score of 2.5 out of that perfect 5 for a sulfite mill. We applied this logic to all types of mills and the different types of depots being considered, such as conversion, solids, liquids, and IDRs, which is the blue section of the table at the bottom. Those are the scores from 0 to 5 given for each type of facility. So then we looked at the site-specific weights for this infrastructure. So infrastructure is more important to an integrated biorefinery than it is for a solids depot. A solids depot doesn't use quite as much equipment, or not as much equipment that's expensive, compared to an integrated biorefinery, which contains the entire process from start to finish. So there's a lot of infrastructure needed there. It's very expensive. So then it's more important when choosing an integrated biorefinery that you pick an appropriate site to save those costs than it is compared to the other types of sites. Another factor that we considered was acreage. This was again more important and weighted higher for certain types of facilities than others. It was more important for a solids depot than it was for an integrated biorefinery or a conversion facility, because the solids depot needed more acreage to store the physical slash and woody biomass in order to break it down. The asset range was on a scale of -5 to 5, with more acreage being better, of course, and then less acreage being less desirable. And we determined through the tax assessor's parcel data how much acreage was present at each site. Then we considered natural gas rates. The cheaper the natural gas, the better, of course. This was also determined on a site-by-site basis. We would look at a site and see in what county it was located and what natural gas rates were offered at that site. You can see it gets a 0 weight for solids depot. It doesn't come in at all because there is no natural gas needed for any of those processes, but it's relatively higher for liquids depot because there is some natural gas needed there. And up next is Christian to continue talking about site-specific assets.
So to continue from where Sydney left off, the next asset we looked at was this includes wastewater permits, air quality permits, and hazardous waste permits. And so what we did was, well, it's important for the facilities we're looking at to have these types of permits so that they can presently have these types of permits so that they can handle the operations and processes that we're looking to utilize for our supply chain. And so what we did was we went to the Department of Ecology's website for each state and we looked for these types of permits by searching the facility name. And we developed a scoring system based on these, what we found. And so if the facility had 3 permits, all 3 of them, it was given a score of 5. And if they had just 2, it was given a score of 2. And if they had just 1 of these, it was given a score of -2. And if they had no permits at all, it was -5. And so the next factor that we looked at was B&O tax rates. This is building and operations tax rates. And so sites are taxed each year based on their assets that they the buildings as well as the operations at these facilities. And so what we did was we looked at the lowest tax rate for our sites and we scored that a 5 and we went down from there. And the next factor that we looked at is boilers. Boilers are important for us, our processes to generate power for conversion and refining especially. And so we looked at whether these facilities had boilers on site currently or if they would need to build one. And so if we determined that the facility had a boiler presently, we would look for the capacity of these boilers. So if a boiler was determined to have a capacity to generate power of 100 megawatts or greater, it was given a score of 5 and down from there. Some of the facilities we looked at, we were able to determine that they did indeed have a boiler, but we were not able to find the capacity for these boilers at all. And so we gave these facilities a score of 0 so that it would not negatively impact their overall score. And then if the site did not have a boiler at all, it was given a score of -5. The next asset that we looked at was whether or not a site had wastewater treatment plant readily available. Wastewater treatment is very important for the processes we're looking to use because there are a lot of chemicals involved in these processes. And so what we did, it's also important for these processes to comply with regulations set by the EPA as well as the Department of Ecology. And so what we did was we looked to see whether or not wastewater treatment was available at these facilities, and if it was given a score of 5, and if not, a score of -5. And so the last factor that we looked at was transportation on site, and this is important for shipping to markets as well as shipping in between different facilities and depots if we choose to go with that method. And so what we looked at was rail and port access on site. So if they had both of these available, they were given a score of 5. If they had one of these options available on site, the facility was given a score of 0, and if they had none of these on site, it was given a score of -5. And so next up, Cody is going to discuss with you some of the top sites we found in the Pacific Northwest.
So from the top, from all these asset factors that were just discussed, we were able to get a top sites for each kind of facility type there is. There's the liquid depot, there's the solids depot, there's the conversion facility, integrated biorefinery, and each everything that's displayed is the site's name, the location, the score received, and the rank. And I'd like you guys to take note that even though maybe a site received a higher score as a liquids depot, doesn't mean that that's what we're examining at versus like a solids depot. Like each kind of has its trade-offs, and that's just the score received based on the factors that we've described. Like for example, there's trade-offs in like the solids depot. You can kind of have more solids depots in an area because it requires less infrastructure and can take in biomass, and whereas a liquids depot requires more infrastructure and can produce a more energy dense material, therefore it requires less liquid depots in that area. We'd also like you to look at, there's top 5 we try to get to a top 5 for each type of facility, but we'd also like you to notice that there's like a 6th in for the solids depot and the integrated biorefinery, and that's just because when we were trying to get to like narrowing them down, some of the sites had such a close score that we thought it wasn't fair to leave those off, and that it still should be kind of examined as a location we're looking at. And we'd like to apologize that the Simpson-Tacoma Craft actually name is spelled incorrectly. It should be the Simpson Timber, so we'd like to apologize for that. And so when looking at these sites, you can kind of see on this map that's about to be displayed that in the Northwest region, they're kind of in the Oregon, Longview, and Washington area, that the Longview area being in Washington, and you can kind of see that where the facilities kind of fall within. And so the triangle displays a solids depot, the circle displays a liquid depot, and the square is an integrated biorefinery. And for the integrated biorefinery kind of falls within, is kind of a little varied in the locations. And when you look at this map, the conversion facility isn't shown, and that's just because when we did this, there's a lot of overlap, and so there's really actually 20 sites displayed on there, but because of overlap, there's really only 8 sites that are being shown, and each site got its symbol based off the highest score that it received in like the previous slide. So like if it got its highest score in as a liquids depot, it got displayed as a liquids depot versus a solids depot. So that's kind of why you can only see 8 here shown, but in the region you kind of see some of them kind of fall in the Longview area and kind of shoot up into the Washington area as well. So with that, our next steps are we're looking into doing a sensitivity analysis, and from there we can gather more site-specific information and look into the companies. Like we're looking into property taxes and kind of going off things that can narrow down but also broaden the gap from one site to another. In our previous presentation, it was mentioned to look into Native American tribal lands, and we're going to continue to further examine that as a possible solution for where we could put a site, or where sites maybe have like tax trade-offs, and then from there we can down our site selection to our best suited locations. We would like to thank you for listening to our presentation. If you have any more information, questions, please feel free to contact us. And if you would like more like further analysis of our data and our math, if you go past this thank you slide, there will be tables that kind of show how we got our calculations and how we got our score. And there's more information if you are maybe thinking that we left something out. So please feel free to contact us, and thank you.
I'd like to thank everybody for joining us again. We're looking at your guys' questions right now. I know a few questions have come in. If you guys do have some extra questions, feel free to look down on right below the video. There's a form. Fill in whatever that question may be. We'll try and get to that. And so we'll go ahead and start off here with just the first question that came in.
Hello again, Matt Jarrett here. One question we did have, and we hope that we talked about a little, but was regarding the solids and liquid sites. A solids depot, some of the advantages and disadvantages of those. The solids depot is a very rudimentary step. It's just a physical breakdown of the biomass. And when you approach, as we did, looking at a solids depot, mill sites are very optimal, and it doesn't require much infrastructure, so it allowed us to look at a very wide range of different sites. A liquids depot, on the other hand, it has a few more processes involved, and that narrowed down the amount of sites that could serve as a liquids depot. However, a liquids depot, the output is more energy dense and with lower transportation costs. However, since it is limited still, we weren't as able to find sites as close to the biomass as we solids depot. We also received another question regarding sites in Montana and Idaho. Our top sites were all in Washington or Idaho, and we do want to say that we did look at sites in Montana and Idaho. However, with our weighting system that we've just described today, those sites did not make it to the top, unfortunately. But we were looking at them, and they were considered in all of our calculations. Thank you.
Again, I want to thank everybody for coming in and watching the webinar. We'll keep you guys posted on any other further developments we have. If you guys want to send me an email, my name again is Carl Olson, faculty member in civil engineering. You can send that to kOlson@cee.wsu.edu. We'd love to hear your comments and feedback. And again, thanks for joining us on this presentation. Bye.